All right, let's look at the limit comparison test. All right, in order to apply comparison test, we have to have a clear inequality. For example, Bn is always larger or equal to An. It's sometimes very difficult to have that, but we can establish that the two series are comparable, right? So one converges, the other one converges, the one diverges, then the other one diverges, right? So here's a way to establish that they're comparable, right? So we look at the ratio between an and bn and take the limit. And if the limit exists and also it's finite, then we can conclude that series with an and the series with bn either converge or diverge together. Right? So either both converge, or the both diverges. Right? All right, so here's an example. Right? Usually you have the original series, which looks very complicated. So this is going to be our an. Right? So this is going to be our an. And then we're going to try to come up with something simpler but comparable. Right? So here's a way to come up with the bn. Right? So what you do is you're going to look for the leading term. Right? So leading term on top is going to be the one with the largest power, and we can even ignore the constant leading coefficient. Well, we're interested in this guy right here. Right? So you have n squared with the square root. So I guess we have to include the square root, right? So that's going to be the leading term on top. So I'm going to write bn. So this is going to be bn is going to be equal to, right? So you have a square root of n squared. Right, then you look for the largest the leading term, which is going to be 4n cubed. So I'm going to take n cubed. Right, so we're basically kind of ballparking it. So we look for the leading term on top and leading term on the bottom, and we can ignore the leading coefficients as well. All right, then if you simplify this, this is going to be, all right, so you can see that the square root and the square cancel out. So you have n over n cubed, and one of the n cancel out. So bn is just n 1 over n squared. All right. So let's determine the convergence of a series with bn. So summation with bn is you can start from n equals 3 to infinity. The reason why it's starting from 3 is that I think when it's 1 or 2, the expression inside the square root it might be negative, so they're trying to avoid that, but that's all it is. So this is going to be summation, n goes from 3 to infinity of 1 over n squared. Right? So this is actually a p-series where p is equal to 2. Right? Which is greater than 1, meaning this is going to be convergent. Right? So you have a convergence p-series for Bn. All right, so let's compare these two. Let's establish that An and Bn are comparable. So I'm going to have to take this limit. So limit as n approaches infinity of an over bn. Right? So you have limit n approaches infinity. Right? So an is this yucky expression. So it's a big square root and 2n squared minus 5n plus 1 over 4n cubed minus 7n squared plus 2. right? Then we're going to divide by bn, so I'm going to just take the reciprocal on the multiply. So bn is a square root of n squared over n cubed, so I'm going to put the n cubed because I have to take the reciprocal, and then square root of n squared, right? Then we're going to try to simplify, right? So this is going to be equal to, right, limit n approaches infinity, right? Let's take the square root together. So if you put the square roots together, you're going to get the 2n squared minus 5n plus 1 over n squared. All right, then you have here n cubed, and then you're going to have a 4n cubed minus 7n squared and plus 2, right? So we can start simplifying it. So this is going to be limit as n approaches infinity, right? So this is going to be a square root, right? So 2n squared divided by n squared is 2, right? And the negative 5n over n squared would be negative 5 over n. And a 1 divided by n squared would be 1 over n squared, right? Then multiply by, right? This one I'm going to actually try to simplify. I'm going to multiply top and bottom by 1 over n cubed, right? So you're going to have 1 over n cubed. That way you're going to have n cubed divided by n cubed is 1. And you have a 4n cubed divided by n cubed is 4. Negative 7n squared divided by n cubed is negative 7 over n. And 2 divided by n cubed is 2 over n cubed, right? Then you can see that, as n approaches infinity, right, 5 divided by big number is going to approach 0. 1 divided by big number square is going to approach 0. And 7 over big number is going to approach 0. And 2 divided by big number cube approaches 0. Alright, so only thing that's left is going to be, right, there's a square root of 2 on top and the 4 on the bottom. That's it, right? But we can see that this is a finite number, so therefore, summation with an and the summation with bn either converge or diverge together. But we already know that the summation with bn is convergent because it's a p-series with p equals 2. So therefore, by limit comparison test, we can make a conclusion that the original summation with an is going to be also convergent. Right? So this is the conclusion. And the reasoning is by limit comparison test. Right? So this is how we apply limit comparison test to determine the convergence of a given series. Right? So when you want to compare two series, if you cannot apply a regular comparison test, then you might be able to try a limit comparison test. All right, that's it. I hope that this was clear.